VLANs are a great way to bring security to your network. But what are VLANs and how do you configure a switch to actually use them? Well, if that's something you're interested in learning, stick around and watch this video, because that's what we'll be going over. Now, rather than just log into a switch and start making changes here, there and everywhere, I think it'd be better if I give you a bit of a background on VLANs and switches to begin with. But if you prefer, you can skip ahead because I've got actual timelines in this video. Now, what we've got here is a diagram of a switch, and we've got some computers actually plugged into it. So, I mean, this is just a stock image, but it's a case of, we've got a PC, for example, which plugs into port number 1 here. We've then got a laptop plugged into port number 2. And then I've got a symbol here representing a firewall, which we've plugged into port number 3. Now, if this is an unmanaged switch, what it means is, well, you can't manage it. You can't make any changes to the switch. You can't change its behavior in any shape or form. It's intended to be a plug and play device, effectively. You can take any computer, plug it into any port, and that device will then have direct access to any other device that's plugged into the switch. Now, for a simple network where you may only have just a few devices, or you're not too concerned about security, that's not really a problem. But if you are concerned about actual security, it is a big problem because there's nothing you can do. You can't change the behavior of the switch in any shape or form. You're just allowing all of these computers to talk directly to each other. So if you've seen my previous video where I was going over home IT security and how you might want to start thinking about improving the actual network security, especially if you've got things like a NAS that's got data on it. If you've got, for example, smart home devices, you want to start separating those sort of devices out. You want to put them into their own network segments. And the trouble is, you just can't do that if it's an unmanaged switch. Now, again, this is a stock image, so don't read into that. It's a case I'm just using it as an example. So what we do actually need is what's called a managed switch. And like it says, then it allows you to actually manage the configuration of the switch, and it means you can actually change the behavior. More specifically, what we're interested in is being able to change the behavior of the ports, or the idea is to create what are called virtual local area networks, or VLANs. In other words, we can actually place different ports into different VLANs, which means we can separate our devices out. If we put them into different VLANs, we're basically putting them into different network segments, and then we're stopping them from actually communicating directly between one another. Now, out of the box, an actual managed switch behaves just like an unmanaged switch does. And that's because what the vendor does is it assigns all of these ports on a switch to the same VLAN, and that's a VLAN number 1, hence why I've got a 1 next to the little cables here. So straight out of the box, this is a plug and play switch. You can just plug a computer into a port and it'll be able to talk to any other device on that switch. So from a sort of like a high level view, you look at it logically and it looks something like this. All of these devices are plugged into VLAN number 1, as you can see here. We've got a firewall that's providing internet access, for example. But what it doesn't do is have any say in these two computers. If they want to talk to each other, it doesn't get in the way. It can't. And that's just because from the switch's perspective, all 3 of these computers belong to VLAN number 1. If you've got a device in VLAN number 1, it can talk to any other device in VLAN number 1. If it's if it's plugged into a port and that port belongs to VLAN number 2, then it means that that device can talk to any other device in VLAN number 2. So if we go back to the physical diagram here, basically what's happening is the laptop here will be sending information to the switch. It comes into the port here, and the actual switch is saying, you belong to VLAN number 1. The laptop then, wants to send that information over to the PC here, and the PC, as far as the switch is concerned, belongs to VLAN number 1, because that's what the port's assigned to. So it allows these two, computers to talk directly to each other. So the traffic literally just comes into this port, goes through the switch backplane and pops out back out to this interface here over to the PC. So all that's happening is you've just got traffic going backwards and forwards between these two ports. Normally, I mean, I'm not going to go into the gist of how switches really work, but normally this firewall would never see any of that traffic. It'll see some of it to begin with and every now and again, but most of the time these two switch ports are just carrying out a conversation between these two computers totally independently of what goes on, for the rest of the switch ports. So out of the box, yeah, we've got this flat network effectively where these two computers can talk directly to each other. And that's not what we want. We want to change that behavior. For example, maybe we don't want these two computers to talk to each other. We might still want them to access the internet. We just don't want them to have direct access to each other. Or maybe we want limited connectivity. And that's where we start making changes by implementing VLANs on the switch. So straight out of the box, we've got the situation where everything belongs to VLAN number 1, and it's not what we want. We want various devices to be in different network segments, which means we need to put them into different VLANs. So instead of having this sort of network design, what we actually want to be aiming for is something like this. So we still want the two devices to be able to access the internet through the firewall, but we don't want them to talk directly to each other, or we want limited access. And so basically what we need to do is to put them into different VLANs. So as an example, we've got a laptop here, and that's in VLAN 100. We've got a PC, which is in VLAN 200. Now the actual number of these VLANs doesn't really matter. I've just plugged them out there basically. Use whatever number is best for you. But the thing is, you've got a range from about 1 to 4094 here, so you've got a big choice of numbers. That's the thing to bear in mind is we're not using names, we're using numbers. You might be able to configure an actual name in the description when we create these VLANs, but ultimately it boils down to the actual number of the VLANs. That's what's the important thing. So what we've got here is a PC in VLAN 200 and a laptop in VLAN 100. And the switch will not allow these two computers to talk directly to each other because, well, they're in different VLANs. The laptop can talk to something that's in VLAN 100, but it can't talk to something in VLAN 200 unless you place a device that's got connectivity to both of the VLANs. And that's where something like a firewall would come into play. Because what we've got here is a firewall that's got an interface in VLAN 200 as well as in VLAN 100. So this firewall would be still the default gateway for these two computers because they'll want access to the internet, for example. Let's say that this laptop, well, let's say, for example, that the PC is doing some music streaming, for instance, and the laptop wants to be able to play that. Well, we could introduce rules on the firewall to allow that. Or maybe it's a case of, well, we don't want anything in this network talking to anything in this network, in which case the rules on the firewall should be, well, nothing can talk to each other between these two networks. But the key thing is now we've got this choice. If you go back to the original setup where all of the ports are in VLAN 1, we can't control anything. The switch is allowing these two devices, for example, to talk directly to each other. As soon as we introduce VLANs and start putting these devices into different VLANs, all of a sudden we've now got this control, and that's what we're aiming for when it comes to security. We've got the final say effectively, as long as the switch is keeping our traffic separated into different VLANs. We've got the say on this firewall as to whether these computers can talk to one another or not. So how do we actually achieve that? How do we get from, say, this, where everything's in VLAN 1, to this, where our PC's in VLAN 200 and our laptop's in VLAN 100? Well, that means we've actually got to make changes to the switch. So if we go back to the way it's set up, these devices, they've all got one cable plugged into the actual switch. It doesn't necessarily have to be that way. I mean, the firewall, for instance, could have an extra interface plugged into a different port, but in this particular example, it only has the one interface plugged into port number 3. In which case, what we've got to do is we've got to modify the switch so that it now looks like this. In other words, we want the laptop to be in VLAN 100 We want the PC to be in VLAN 200, and we want the firewall to be in VLAN 100 and VLAN 200. So the firewall has one interface plugged into the switch, but it can talk to both of the VLANs. Now, I have actually done another video on how to set up a firewall like pfSense, for example, to be able to do that. How you set up what is a VLAN aware firewall to support multiple VLANs on a single physical interface. Although, as I said, you've got the choice where you could have, for example, one cable plugged into port number 3. If the firewall's got another interface, you could plug that into this port down here. That one could belong to 100, that one could belong to 200. Really comes down to, how you want to do it. But for the sake of this example, we're going along with one interface plugged into one port, and the firewall is what's called VLAN aware. In other words, we can break that physical interface up into logical interfaces, each belonging to a different actual VLAN. Now, the one thing I should actually point out before I start explaining how we configure the switch to achieve all this is to do with the IP addressing on the actual network. So when you start off, you'll start off probably out of the box, unless you've made some sort of changes to your own network, where all of the devices are in VLAN 1 and they all belong to this 192.168.1.0/24 network. That's just the way that they tend to be by default. That seems to be the common sort of IP address range that vendors use these days. But the thing is, the firewall will want to see devices in different networks. So not just different VLANs here that we're talking about different IP address subnets as well. So that's something to bear in mind here. So for example, we might decide to keep this 192.168.1.0 network for VLAN 100, but we're then going to have to introduce a new IP address range of, say, for example, 192.168.2.0 to VLAN 200. So we've got different IP addressing on this side of the network and different IP addressing on that side of the network. So that's just something to bear in mind. It's not just a case of we can just make some quick change to the actual ports on the actual switch and hey presto, everything's still on the same network and everything's all working tickety-boo. It doesn't work like that, unfortunately, at least not this way. When you configure the firewall, it'll have an interface in this network, and then it'll have an interface in that network. And we've also got to then start supplying new IP addressing to the computers in this network. I mean, you don't necessarily have to keep this particular IP range. And to be honest, I wouldn't recommend you do anyway, because it's a blatantly obvious IP address range for a hacker to target if they actually get access to your network. So I would probably change that to something completely different. But either way, it's just something you're going to have to bear in mind, is there's more to it than just changing these VLANs. So now that we know that to separate our devices out from each other, we have to put them into different VLANs. What sort of configuration changes do we need to make to the switch to get, say, the laptop into VLAN 100, the PC into VLAN 200 and so on? Well, one thing to point out is that when it comes to retail switches, all they know about are VLANs. They don't know anything about the IP addressing, so we can't make any changes on the switches to actually influence IP addressing. I mean, you can on higher end professional switches, but retail switches, it's just VLANs. All you do is basically assign VLANs to ports, and then, whatever port that PC or laptop's plugged into, well, that's the VLAN they belong to. When it comes to changing the IP addressing, that's a different video altogether. I mean, we're into the realms of, making changes within DHCP servers, for example, or manually assigning IP addressing on the actual computers. Now, I did do a video on how to do this sort of thing within a lab, for example, if you want to create your own Linux server that runs DHCP, for example. You could also configure a DHCP server on a firewall like pfSense, for example. So it's the DHCP server for VLAN 100 and 200, but as far as this particular video goes, we're just interested in the VLANs because that's all the actual retail switches that out there can support typically. So what actual changes do we need to make then to actually change these VLANs? How do we go from a switch that's configured like this, where the actual computers are connected to VLAN 1, for instance, to this where the laptop's in 100, the PC's in 200, and the firewall's in 100 and 200. Well, it does vary slightly when it comes to the vendors. They do things slightly differently, but the process and the principles that we're using is pretty much the same, no matter which vendor you actually go with. So the first thing you have to do is to actually log into the switch because you want to be able to manage it. And then what you have to do is find out a section that's typically called VLANs, for example, because that's where we create VLANs. Now, a switch will support anything from VLAN 1 to 4094. It's a big long range, but typically it'll only know about VLAN 1, or that's the only VLAN that's been created on the switch. So it is capable of supporting more. It's just out of the box, it only supports VLAN 1. Now, it is slightly different for like Netgear switches. They tend to support VLANs 1, 2, and 3 out of the box. But in any case, we just don't want to touch these default VLANs anyway. That's the reason why I've got these, these numbers here of 100 and 200. It's just a kind of an industry practice to keep away from these default VLANs. I mean, I won't get into the security details, but it is a recommendation I would suggest is come up with a plan for all the different network segments that you need, and then come up with a particular number in that range, and put aside a VLAN for every individual network segment. So in our case, I've got two network segments. One is VLAN 100 and one is VLAN 200. So the first thing then is literally to just connect to the switch, look for a VLAN tab, some section within the configuration to do with VLANs, and typically there you'll be able to then create your VLANs. So what we would do is create a VLAN 100 and a VLAN 200. That would be step number 1. Now, chances are you might be able to give these a name, you might be able to give them a description, but from the switch's perspective, that's just for your own benefit, really. It has no meaning to the switch. It's just interested in the numbers, that's it. So once we've actually created the VLANs, we've actually got to then start assigning VLANs to these ports. And it's always going to vary depending on what the actual device is that's plugged into it. So these two devices are what we call end devices. They're not VLAN aware. They could be, but from a security perspective, we don't even want them to be. The actual firewall, on the other hand, we trust the actual firewall, and that is VLAN aware. I mean, it's going to have logical interfaces. For example, it's got one physical interface, but it's going to have logical interfaces in each of these two VLANs. And we've got to be able to basically trust the firewall to tell the actual switch which VLAN the traffic belongs to. Likewise, when the switch needs to send traffic to the firewall, it needs to tell the firewall which VLAN the actual traffic belongs to. So we do trust the firewall. We don't really have much choice, really, because we're splitting up this physical interface into multiple logical interfaces. But when it comes to end devices, that's a whole different ballgame. Even if they are actually capable, and most operating systems are, we do not want them to be VLAN aware. We don't want them to be like the actual firewall where they can influence which VLAN they belong to, because then that's a security risk. So for example, if we allowed this PC to talk to VLAN 100, well, there's not much point really. We actually want this one in VLAN 200. We want the actual laptop in VLAN 100, and we don't want the user actually changing that decision. We want to keep them, separated, and we want the actual switch deciding which VLANs they belong to. So the configuration change at this point will be slightly different, again depending on the actual endpoint device that we've got here, but also depending on the actual manufacturer of your switch. But typically what it involves is a step 2 where we actually tell the switch which VLAN, well, which ports I should say, a VLAN can actually be used on. So the ports themselves can support multiple VLANs at the same time. And this step 2 is to actually tell the switch which VLANs can be used on a port. So in this case, all of the ports initially are able to use VLAN number 1. But what we would do is look for a slightly different section within the configuration. I mean, it might be called VLAN membership, for example. There, what you do is you actually select the VLAN where you want to then assign it out to different ports. So for example, we would pick VLAN 100, and then we might get a sort of like a long list of all the individual ports, and then we'll select exactly which ports that VLAN can be used on. So in this case, we would say, well, we want it to be used on port number 2 and port number 3, because the laptop needs to be able to get access to VLAN 100, and so does the firewall. And then when we come to to the actual VLAN 200 for the PC, we'll select VLAN 200. Again, we'll get our big list of ports. And for that one, we'll say, well, we want that to be used on port 1 and port 3. The only thing is it's going to then vary depending on the manufacturer as to what happens next, because it might be a case of they actually want to tell you, well, how do I actually treat the traffic on this actual port? That seems to be a common theme, where you've actually got to tell the actual switch, are you expecting any traffic coming into this port to be tagged or untagged? And then what you typically have is like a little checkbox where you click the box, and initially it might be untagged, then you click it again and then it's a tagged port, click it again and then the VLAN isn't supported on that port. So it varies depending on the vendor. I mean, it'll become a whole lot more simpler and a lot more easier to understand once we go through an example, but literally what we're talking about here is that this device here is an end device where it's not VLAN aware, so it's not going to be telling the switch, and we don't want it to tell the switch which VLAN it belongs to, in which case that's referred to as untagged traffic. And now the firewall, on the other hand, is VLAN aware, and the only way for the switch and the firewall to be able to distinguish between, what interface belongs to which VLAN is through this tagging process. So when the firewall, for instance, needs to send traffic into VLAN 100, it tags that into that actual traffic with 100. When it wants to send traffic for VLAN 200, it'll tag it with 200. And that way, when it gets to the switch knows straight away, all right, okay, you've got a tag of 100, then it belongs to VLAN 100, and vice versa. The switch does its own tagging when it sends traffic to the firewall. So we've got these two ports here. If the vendor is asking about tagged or untagged traffic, these two ports would be untagged because A, we don't expect any traffic to be tagged, but B, we don't want traffic to be tagged. We don't want to give these devices the opportunity to change to a different VLAN, because that would just break the security that we've got in place anyway. Whereas this particular port for the firewall, we're expecting it to be to actually tag that traffic. And it's a case of we have to tag the traffic going to the firewall. So we'd assign that particular port as a tagged port. So once we've done that, the next step is, well, we've got to do something slightly different when it comes to these two devices here, because these two devices, they're kind of like pinned to one and only one actual VLAN. So what we've got to actually then do is go to another section, and it's going to vary depending on the vendor again, but it might be a case of they call it primary VLAN IDs, or it might be the actual native VLAN or the default VLAN or something. It's all about what happens when you've got traffic coming into these switch ports that isn't tagged. What VLAN should it belong to? And that's mostly going to influence devices like these that A, we don't want tagging traffic, and B, we don't expect tagged traffic. So these are our untagged ports that it's more useful for. But in this particular case, when it comes to port 1, we'd get to this section and we'd select that specific port number 1, and say that the primary VLAN ID or the native VLAN or the default VLAN is VLAN 200. So when this PC sends traffic to the port, then the switch itself tags it as belonging to VLAN 200. When the laptop is sending its information, we have to tell that port that its default VLAN, primary VLAN, native VLAN is VLAN 100. So the switch is then forcing the traffic to belong to a specific VLAN. Now, this particular port is slightly different. I mean, we're going to trust this firewall to do the right thing because, well, we'd expect to be the ones configuring it in the first place. But technically, we don't expect any traffic to be actually untagged, but there is the potential. Now, to be honest, if this actual firewall got hacked, there's much bigger problems that we've got, quite frankly, anyway. But when it comes to security best practices, the idea is any traffic that comes into that port which is untagged, we want to really drop it. We don't want to sort of like have any problems, because there is a security risk when it comes to untagged traffic. Again, I don't want to really get into the details about it, but when it comes to that specific port, what we want to do is we want to pick a VLAN that's not used, and we want to set that as the primary VLAN ID or the native VLAN. And the idea is, if for some reason this firewall were to send traffic to the port and it's not tagged, it ends up in a VLAN that's not getting used anywhere else on the switch, and it helps us get around a potential security risk. I mean, again, it's a case of, for a home user, that's probably not that big of a deal, but because it's like a best practice for security when it comes to switches, it's something we'll just go along and do. But once we've made all these changes, once we've created the VLANs, once we've told the switch, which ports can support which VLANs, and then when it comes to these devices in particular, these two ports, we've told it which specific VLAN is the primary VLAN ID, for example. That's it. The switch is, all of a sudden, it's now functioning differently. All of a sudden, this laptop will be in VLAN 100, this PC will be in VLAN 200, the firewall, well, it's up to the firewall as long as it's configured properly. It'll be able to communicate in VLANs 100 and 200, and that's it. Hey presto, everything's changed. But the one thing to bear in mind is they still support VLAN number 1, and that's something we don't want. So what we would do is a sort of like a final step, if you will, as a bit of a best security practices, we'd actually go back to the little section about the VLAN membership, for example, and we'd actually remove VLAN 1 from the ports so that these devices can't access VLAN 1. And that way, if somebody were to get access to VLAN 1, well, it doesn't matter. These devices won't be able to talk to VLAN 1, in which case we're fine. These are all nicely separated out into their own specific VLANs, and it doesn't really matter if somebody, connects a device in VLAN 1, they can't talk to these because they don't know anything about it, or at least the ports don't anyway. So hopefully I've covered it in enough detail, but it's probably like quite long-winded, I must admit. And it'll be a lot easier to explain if we go through an example. One thing to bear in mind, though, is once you start moving to different VLANs, you've got to bear in mind that the switch, by default, it'll have an IP address, a management IP address assigned to it, and that's listening and communicating on VLAN number 1, and that is something we're going to have to change. We're going to have to go into the system configuration of the switch, and we're going to have to move that interface into whatever is our most trusted or secure VLAN, because we don't want that in VLAN 1 either. It's a bit of a risk when you do it, because you could end up locking yourself out if you don't do it properly. But we'll go over that all in an example, and I'll go through a couple of vendors to show you how things vary. Well, thanks for making it to the end of this video. I really do hope you found it useful. If so, then do click the like button and share, because that encourages YouTube's algorithm to suggest it to other people who might find it useful as well. If you're new to the channel and you'd like to see more content like this, then yeah, do subscribe. Just remember to click the little bell icon though, that way you'll get notifications when I send new content out. If you've got any comments, any suggestions, if you want to leave any feedback at all, please post that in the comments section below. And if you'd like to support the channel, I've left links to both Patreon and PayPal in the description below. But above all, thanks very much for watching. I'll see you in the next video.